Hey you guys, I thought I would just get on and make a quick video about this problem. As soon as my pen works, I can grab my pencil tool. There we go. Okay, so it tells us that the lateral faces of this square pyramid are equilateral triangles. So the lateral faces are just those faces that are basically on the outside, all the outside edges. Sometimes it's hard with three-dimensional shapes to kind of get an idea of what they're talking about. But if you think of well, this isn't a cone, but if you think of like an ice cream cone or even like a Rubik's Cube is the square, this is the same idea being a pyramid. You're talking about that outside surface, those flat edges. And it's telling us it's an equilateral triangle. So that's a really important information because that means all the sides are equal of all of the triangles. So it wants us to find the surface area to the nearest tenth. Only round at the last step. Okay, so you do have your formula sheet that you're able to use, and I pulled this from your formula sheet. If you need that formula sheet, let me know. I'll send it to you. But you're allowed to use it in your course and on the SOL. I guess you can confirm that with your teacher as far as using it in the course. But because you get it on the SOL, I allow my students to use it all year. So we want to do surface area here. So we're going to need L and P and big B. So let's start with big B. Big B is the area of the base. So the base of this shape is right here. And it's a square. Because they're equilateral triangles, remember, all of these are 18. Everything's 18. So the base of a square is length times width. So it'd be 18 times 18. We need little p. Little p is the perimeter of the base. So the perimeter, remember, you add up all the edges. So that's going to be 18 4 times, right? And these numbers are huge. I do not know those answers. I'm going to grab my calculator. 4 times 18 is 72, and 18 times 18 is 324. So we have little p, big B. Now all we need is little l. So you can see from the diagram, little l is the slant height here. It's the height along the side of that triangle. So if we were to drop a line down from the vertex of this triangle, like here, and we would go right to the middle of the edge across from it. So we would break this piece into two equal pieces. We would bisect it. So those would be 9 and 9. We made a right triangle here because we did a perpendicular bisector. So because this is an equilateral triangle, remember that all of the angles are also equal. So this angle is 60, this whole angle is 60, and this one is 60. So if we bisected this one face of that triangle, that makes each of these 30. See, I cut that 60-degree angle in half. Now look what we have. We have a 30, 60, 90 triangle. So remember, in a 30, 60, 90, we have some very special side length relationships. So the side across from the 30-degree mark is our x, always. So x is 9. The side across from the hypotenuse is always 2 times x. In this case, that'd be 2 times 9, which is 18, which that makes sense, right? Because that side is 18. We know that. And then the side across from the 60 is always x root 3. So again, our x we said was 9. So this side is 9 root 3. There we go. We found that slant height by using special right triangles. So the slant height is 9 root 3. And the only reason we were able to do this is because they told us they were equilateral. So that made it a very special triangle. The 60 degrees in all the angles and 18 on all the sides. So now that you have all three things you need, we just plug it in. 1/2 times little l is 9 root 3. And little p is 72. I feel like I'm saying rapper names. Little p. Big B is 324. There we go. Now I know you can definitely plug that into your calculator. And I'm going to do that when I send the email out to you, but I just want to stop this recording now because I'm popping over to another meeting. I hope that this helped, and just let me know if you still have any more questions. Bye.